Hi everyone. Today we are going to talk about creating a codebook and a database. So just to orient you a little bit to where we are, sort of in the semester, we're at that point where we're going to start to talk about data analysis. And so in order to get sort of data ready for analysis, what we have to do is get it into a format that we can analyze. And can use programs like Excel or SPSS, that kind of thing. The instruction that I provide is really based in Excel, but spreadsheet programs are pretty similar, and so some of what I'm talking about will apply to other programs as well. So let me just give you a rundown of what we'll talk about here in the course of this lecture. We'll do some terminology. Then we'll talk about sort of what a codebook is. Review levels of measurement, and then actually get into creating the database. So before we begin, a little bit of terminology. So data is just really numbers or scores generated by a research study. We generate data sort of during the course of single system design, right? Every time we take a measurement, that's a piece of data. So data might be something like the number of hospitalizations, score on some kind of assessment tool. Here I've used the mini mental state exam, but something like the Beck Depression Inventory would be a sort of another example, or the Patient Health Questionnaire 9 would be yet another example. Data could also be sort of a Likert, the response on a Likert scale. Information is, just to sort of add a little bit of nuance to this, information is data that's been analyzed and interpreted in some way to give meaning to those results. And so if we were to take some examples from that previous bullet point about data and sort of turn it into a piece of information, we might say something like the number of hospitalizations declined after implementing a new service, or a score on the, some assessment tool decreased or increased or went in some desired direction. Variables and values, for example, let's talk about these next. So variables are just characteristics that differ among participants in a study. And then values are simply the different quantities of a different value. Values are different quantities of a variable. Sorry about that. And value categories are different groupings within a variable. So let me give you some examples right here. So an example of a variable that would sort of capture a characteristic that would differ among participants in a study. Let's say something like age. So age would be the variable, and it's capturing the characteristic, how old the person is, among all the different people in a particular study. So people might be 25 or 35 or 60 or 92 or something like that. The value would simply be that different age, right? And that's why I've used 65, 66, 67 here in the example. Value categories would be something like gender, male and female. Might be something like religious orientation, might be something like state in which a person was born, or country in which a person was born. Could also be something like whether or not they like pepperoni on their pizza. Could be something like yes or no. Okay, so moving on. Variables, if you think back to last semester, variables can be continuous. They can be dichotomous. We'll talk briefly about this thing called a dummy variable, or dummy coding. Actually, why don't we do that now? So remember that continuous variables typically go from 1 to 5 or 1 to 10 or something like that, and the difference between each of the numbers on that scale is meaningful. So a Likert scale is often a continuous variable. If we're talking about strongly agree, sort of a 5 score or something like that, and strongly disagree is a 1 score, then there's some distinction, there's some meaningful difference between a 5 and a 1. A dichotomous variable is simply yes or no, 0 or 1, black or white, up and down, that kind of thing. When we dummy code something, or when we create a dummy variable, we assign one category a 0, and we assign the other category a 1. So oftentimes we want to compare, let's say, differences between gender. So we would assign members of one gender a 0, we would assign members of another gender a 1, and that would let us compare some other score that we were using. So developing a codebook from a survey. Let's sort of talk about what a codebook is here real quick. A codebook is sort of what researchers or other people who are going to be accessing a database. It's what they use to sort of interpret the scores or interpret the numbers that would be in that particular database. So a codebook does a couple of things. It provides a description of each data element or each field in the database. Another way to think about that would be that a codebook provides a description of each variable in a database. I'll give you some examples here in a couple of slides. It contains a detailed description of what should be entered in each data element or each field or for each variable. And then it contains a legend of codes for each of those variables. Again, examples coming up here later on in this talk. So we use codebooks as sort of a reference guide for existing databases, for an existing database. Sorry about that, my phone is ringing. We use it as a training manual for people learning how to enter data into a database. We use it as a quality control tool to sort of ensure uniformity and consistency in entering data and analysis. So typically what's included? The name of the variable is always included. Variable names must be unique, so you can't repeat a variable name in the same codebook. If you have completely different databases or completely different codebooks, and you want to use the same variable name, that's fine. But if we're talking about the same database and the same codebook, the variable name has to be unique. And that typically goes at the top of a column. Then we need a description of the variable. So what question number was it on a survey? And then what is the text of that question? So a simple example, the very first question we might ask on a survey is, what is your age? And so the question number obviously is 1, and then the question text is, what is your age? So what a codebook does is it sort of aligns that variable name with that variable description. Then the next thing that's included is the value label. And so what is the sort of format of the values that would be included in that variable? Is it numeric, right? So is it age, something like 65, 66, 67, or is it categorical, where we have a 0 equaling no and a 1 equaling yes? Again, examples coming up here in a few minutes. And then we also have to say what happens if we have missing data. So we have missing data when people refuse to answer questions, or they don't want to, or they answer them incorrectly. Oftentimes, most of the time, we have missing data because people simply say, I don't want to answer that question, and that's fine. They're allowed to say things like that. Now, I put a note on here. Let me back up. So missing data, we have to sort of specify what values are considered missing data. So what I've mentioned here on this slide is that we shouldn't leave any of the fields blank. So we shouldn't leave any of the boxes blank in that database. If we're using Excel, we actually have to use, or we have to leave missing fields blank. That's how Excel handles missing fields. If you're using something like SPSS or SAS or something like that, you can actually specify a missing value. You could say if the number 99999, right? So 5 nines, if 99999, if we have if you see that in a particular field, that means the score is blank, right? That means it's a missing value. If for example you saw the score 99999 in an age variable, that would sort of clue you into the fact that that's a missing value, because it's frankly impossible for a person to be 99,999 years old. But again, for Excel, we do have to leave missing values blank. That's just one of the sort of idiosyncratic things about Excel that distinguishes it from something like SPSS. If as you're setting up a codebook, you do want to use a value like 99999 for missing data, you can do that in Excel, and then we can deal with how we do that later. But you're also able to leave them blank. And then the last thing you have to include in a codebook. Let me move my picture real quick so you can see that. The last thing you have to include is the level of measurement. Is it a nominal variable, an ordinal variable, or an interval or ratio variable? So, moving on here. Quick review: levels of measurement. We have from last semester, we talked about different levels of measurement. We talked about nominal and categorical variables. We talked about ordinal variables, and then we talked about interval and ratio variables. This semester, we're collapsing these into sort of three different categories. Last semester, we would have learned about these in 4 different categories. So we would have last semester we would have learned about nominal or categorical variables as sort of one category, ordinal variables as a second, interval as a third, and then ratio as a fourth. This semester, we're going to collapse interval variables and ratio variables. There is a fourth kind that we won't really deal with, string variables. I'll talk about what those are in a second. It is important to specify the different level of measurement for each variable, because the level of measurement sort of determines what kind of analyses you can do. And so this week's material is really about setting up a codebook in preparation for data analysis. And so when we get to that later on, this is one of the things that sort of has to be in place, because the level of measurement informs the kind of analysis you can do. So, quick review. What is a nominal or a categorical variable? So if you remember that sort of root of nom, like a nominal variable is nom. It's a name, right? It's a category simply is just a name of the characteristics of the variable. We then assign numbers to the different categories. They're just labels. We're not ordering the numbers in any way, so we're not saying a 2 is better than 1. We're not saying a 3 is better than a 1. We're just using that to distinguish the different categories that are possible. So if you remember, one of the terms that we used last semester is that categories must be exhaustive and mutually exclusive, or mutually exhaustive. That means if you're in one category, you're not in any other categories. So if you're a 1, you're definitely not a 2 or a 3. And we have to provide people with all of the different possible choices. That's what exhaustive means. And so there we go. Exclusive, mutually exclusive and exhaustive. Right. So examples of nominal or categorical variables are things like gender or marital status. I was recently working on a data set, and there were, I believe, 7 different choices for marital status. There was single, never married. There was single, divorced. There was single, widowed. There was single, separated. There was there was married. I believe there was married. Yeah, there was married, and then there was cohabitating. And all of those things, so we evaluated that to be both an exhaustive list of all the possibilities, and then mutually exclusive, because if you were in one of those, you were not in any of the other categories. All right, ordinal variables. So in an ordinal variable, what we're doing is we're simply rank ordering things. So we can put these different categories in a specific order. And each of the categories, have sort of a specific, characteristic. So this, we often call ordinal variables. We often call ordinal variables, just sort of ordered category or ordered categorical variables. One of the distinctions of an ordinal variable is that there is no equal interval between categories, so there's no sort of quantifiable meaning between the different labels. So when we talk about things like problem severity, that's often an ordinal variable. We often measure income as sort of an ordinal variable, and that's one of the examples we used last semester. As with categorical variables, ordinal variables must be mutually exclusive, and they must be mutually exhaustive. So here's an example real quick. Level of education. We might say that a 1 is equivalent to less than high school, 2 is equivalent to a high school degree or some kind of equivalency diploma, 3 might be equivalent to some college, and 4 might be equivalent to to a college degree or higher. So let me say one more thing about this before we go on. So these are mutually exclusive, and they are exhaustive. So this captures every possible choice or every possible option that a person could have. And if a person is a 1, for example, that means they do not fit in category 2 or 3 or 4. If they fit into category 3, for example, they do not fit into category 1, category 2, or category 4, and so on. You could sort of make that argument for every choice in there. So interval variables are ranked just like ordinal variables, but they are also equally spaced on a continuum. And what we mean by that is that the distance between numbers have meaning. So the distance between $2 and $4 is the same. I'm sorry, the difference between 2 and 4. I was going to use dollars as an example here in a second. The distance between 2 and 4 is the same as the difference between 4 and 6. And sort of money is a good example of that, right? Having $4 is $2 more than having $2, and having $6 is the same, is $2 more than $4. So you can sort of, that distance piece is the same. In an interval variable, there is sort of no true 0 point. 0 is pretty arbitrary. So good examples of that are things like temperature or IQ. Money is also another good example. You can have negative dollars, right? You can have negative money. That simply means that you owe people. You owe money to someone or something. And so 0 is sort of just an arbitrary point on that number line. Ratio, again, same as interval, but it does have a fixed or absolute 0. For example, age is sort of a good ratio variable. Obviously, a person who is 0, right, they haven't been born yet, so there's sort of a meaning assigned to 0. But as with money or temperature, right, the difference between 2 and 4 and the difference between 10 and 12 is significant when we're talking about age. And the distance between any numbers on that number scale is meaningful as well. So let's talk about codebooks now. The way that typically I do codebook stuff is I get out a pencil or a pen or whatever I have laying around. And and I just write on a blank copy of the survey. Typically for the first time, when I start to enter data, because entering data has to be a sort of really precise operation, really precise process. Typically what I do is I will just code the values on individual paper copies of the individual paper copies of the survey, which then makes entering the data into Excel or SPSS or whatever it is I'm using much easier. And I'll show you some examples of that here in a couple of minutes. So, a database is nothing more than a place where data is stored. When we worked on our single system designs, you in effect created a database because you put your data into Excel. So you've had experience with this already. Database programs, as I said, there's lots of them out there. I think Excel is probably the most common just because it's a Microsoft Office package, but there are a number of other ones. Again, when we talk about data analysis and creating databases and things like that, we're using Excel. If you want to talk about some of these other programs, we can do that sort of individually. So get in touch with me if you want to talk about SPSS or something like that. So what should a database contain? A database is sort of where the codebook and sort of data meet, right? So we talked about sort of what a codebook should contain before. The codebook is sort of the roadmap, right? It's the key, it's the legend, it's the way to understand all of the stuff that's in the database. So this is sort of where these two ideas kind of merge. So we're going to go through step by step here. What I'm going to show you in these next couple of slides are screenshots of different things. You've got a couple of just sort of generic surveys. They're just things that I created. So if you want to practice this, you can. There is no, in 514, there's no assignment related to creating a codebook or anything like that. But some of the other assignments will sort of require you to understand how these things are created and how to interpret it. So if you want to practice, you're welcome to. And like I said, you can just do that in Excel. And you can use the different, the couple of surveys that I uploaded here and then sort of create your own codebook. So this is typically the process that we go through. We review the survey responses, we create variable names, we assign value labels, we determine the variable level, and then we put all of that information in a codebook. So let's look at the survey responses first. And so this is just a screenshot of two of these these different surveys that are available to you on UB Learns if you want to sort of do this on your own. And so this is, again, just sort of a generic survey that I created. It's 10 questions long. Question 1 says, for example, in which program do you currently provide supports? Circle only one. Option A is the parent-infant program. Option B is the parent-young-child program. And we can just, again, for the example here, for the sake of example here, assume that the person who completed this survey works in program B, which is the parent-young-child program. Question number 2 is an open-ended response. Question number 2 reads, what is the average number of children living in the home where supports are provided? And the person who completed survey number 1 answered 6. So on and so forth through the 10 questions on the survey. So the first thing that we're going to do is we're going to create variable names. And so this is that same number 1 survey. And what I've done, what I've written on here are the different variable names that we're going to use for each of these different 10 variables. Now, what I've written also on the top right-hand corner of this particular survey is I've written number 1, like hashtag 1, And what I'm using that for is the ID variable. So we have to be able to refer back to the paper copy of the survey if we needed to for some reason. Maybe there's something doesn't make sense, or there's a mistake with data analysis, or so we have to be able to go back from the database to the paper copy of the survey, and using an ID variable is how we would do that. So we might call that variable student ID. Question number one is, in which program do you currently provide supports? We might call that variable PRG used, PRG-USED. You can see I've kind of written that right next to the question number one variable there. And that simply is shorthand for program used, right? Question number two, the text of which read, what's the average number of children living in the home where supports are provided? We might call that variable AVG-CHLD-HM, which is sort of shorthand for average child home, right? In terms of creating variable names, there really are no hard and fast rules. They've got to have meaning for the people who are going to use the database. So things like, some variables are really easy to sort of create names for, like age, or DOB for date of birth, or gender, right, for gender. But some things that are much more specific to particular studies are much more difficult to create names for. Some people ask me, well, can't we just use question one to refer to, or can't we just use the number one to refer to the first question? You could, but let me tell you what the problem with that is. The problem with that is if you put the codebook if you put the database down for a while, and then you come back to it, say, a month later or a year later, and this often happens in research and in program evaluation stuff. You don't work on something for a while. You have to refresh your memory, right? You have to say, oh, what was variable one again? And you have to refer back to a paper copy of the survey. On the other hand, if you've used a descriptive variable name like PRG used, that sort of is a cue, right? It's a reminder to whoever's using that database about what that variable was. The second reason I recommend not using just numbers is because if people are different members of a team, right, different members of an agency, different members of a research team, are all using the database or all interacting with it in some way, having a descriptive variable name sort of provides that that shared vocabulary, or that common vocabulary. At any rate, you can see sort of the second step that I would engage in here, which is to sort of label all of the variables on the individual paper surveys. Next thing we have to do is assign value labels. So again, this is that same survey, and what I've done here for next to question number one, again, the text of question number one is, in which program do you currently provide supports? And the choices were the parent-infant program or the parent-young child program. So if a person answered A, we would assign them a value label of 1. If they answered B, we would assign them a value label of 2. The person who answered survey number 1 happened to circle B, which means they would get a 2 in that for that particular variable. We might, so for question 2, which was an open-ended question, question number 2 said, what is the average number of children living in the home where supports are provided? We don't need to create value labels there, since we know that whatever number a person wrote down would correspond to the sort of average number of children living in the home. However, for question number 3, we do need to provide value labels. So question number 3 reads, do you have cases where the number of children present in the household or the nature of the adult conversations make it more difficult for effective work to be done? And the options are yes or no. We're calling that variable difficulties. And If a person responded A, which is no, we would assign them a 0. If a person responded B, which is a yes, we would assign them a number 1. The number 1. This, by the way, is an example of a dichotomous variable. It's also an example of a it's also an example of a dummy-coded variable. So maybe we wanted to compare the people who answered 0 with the people who answered 1. That would allow us to do that. You can see again here. We'll go through the rest of these. Number 4, the question or the text of number 4 is, how do you envision using a family support worker? The variable name that we're using for that is env_use. So envision using, right? That's sort of the shorthand that we're creating, shorthand that we've created. And the options, the choices are diversion, teaching, transportation, or accompanying. So again, sort of following the logic of the codebook, if a person answered A, which is diversion, we're assigning them a 1. If they answered B, which is teaching, we're assigning them a 2. If they answered 3, if they answered 3, that meant they circled transportation. And if they answered D, accompanying, that means we would assign them a number 4. I think I said something wrong a second ago. I think I confused the 3 and the C on transportation, but I think you know what I mean. If you don't, get in touch with me. And you could sort of see how we would go through and do the rest of all of these different variables, right? We would, for all of the one in which there were sort of discrete choices, we would assign these different value labels. And so you can sort of follow along here with what I've done. So next thing we've got to do is determine the variable level. So right when we determine the variable level, we have to determine, is it a nominal or categorical variable? Is it an ordinal variable? Or is it an interval or ratio variable? There was that fourth category, a string variable. That's what we're going to talk about here in a second as well. So again, back to that same response number 1 on, or survey number 1. So number 1 is a nominal variable, right? This is a categorical variable. A person could work, or a person could provide support in either the parent-infant program, or they could provide support in the parent-young-child program. We're assuming here that if you work in one, you cannot or do not work in another one. We'll just assume that that's, what the story is here. And so these categories are mutually exclusive and they are exhaustive. Again, we're assuming that this particular agency has these 2 programs and that's it. They don't have any other programs. And if you work in one, you can't work in another. So this would be a nominal program. I'm sorry, a nominal variable, nominal or categorical variable. Question number 2, the level of measurement there is interval or ratio. So the text to question number 2, what's the average number of children living in the home where supports are provided? Again, this person answered 6. So it's interval or ratio because we can rank order the different responses, and the distance between any 2 responses is meaningful, right? So there's 6 children living in this particular home where supports are provided. If another home had 8 children living there, that distance, that implies there's 2 more children living there, right? And that's obviously there's a meaningful difference between 6 and 7 and 7 and 8, right? And the distance between all of those is the same. So you can imagine where we're going from here. We have to sort of assign labels to all, or assign variable levels to all of these different variables. And so question number 3, which was, do you have cases where the number of children present in the household or the nature of the adult conversations make it more difficult for effective work to be done? It's another nominal variable. Same thing with question 4. How do you envision using a family support worker? Question number 5 is an ordinal variable. So question number 5, let me read that to you real quick. It says, indicate the extent to which you agree or disagree with the following statement by placing an X or circling the most appropriate box. And the statement is, if available, I would utilize the family support worker in my work with clients. And so the choices are strongly agree, neutral, disagree, or strongly disagree. And this particular person circled B for agree. When, if you remember from last semester, when we use that sort of strongly agree to strongly disagree language, that's a Likert scale. And Likert scales are examples of ordinal variables. So questions 6 and 7 would be interval or ratio levels. Questions 8 and 9 would be nominal as well. And then question 10, which we haven't talked about yet, would also be a nominal variable. Question 10 reads, what improvements do you suggest for the program where you currently provide supports? This particular person wrote improve access. So this is an example of another open-ended question. There's a sort of a wide open range of potential responses. This also would be the string variable, right? So a string variable just means a text variable. String variables can be sort of different length. They can, they don't follow a specific format, and so they're often text variables. Okay. Next thing we have to do, place all of this information in a codebook. Now we haven't really talked about creating a codebook yet, but when I create codebooks, I just create them in Microsoft Word. You can create a table if you want to in Word. You don't necessarily have to. This is just the format that I'm using here. Let me move my picture real quick so you can see the top of the codebook. You can use, sort of whatever you want. I just find it's easiest to do it in Word. If you don't want to use a table, you could use bullet points. That would be fine as well. But again, this is sort of the information that has to be contained in there. So let me show you what's sort of going on here. In this table, what I've done on the horizontal here across this row is I've listed variable name, variable description, which is question number and question on the survey, the value label, what the missing data is, and what the variable level is. And then this is exactly what we've been talking about this lecture. And I've just provided all of that information for each of the different variables here, right? So, for the difficulties variable, for example, we've got the variable name, we've got the number on the survey in the text, we've got what a 0 stands for and what a 1 stands for. Again, a 0 stands for no and a 1 stands for yes. We could specify a 99 or a negative 99 as a missing data, as the value for missing data. And again, this is the variable level of measurement. So we've just taken all of that information from the survey and we've just sort of put it on here. And this would be the key to how we would sort of interpret all of the information on a paper copy of the survey. So, steps to creating a data set. Again, we've done this already, but I'm just going to walk through it in case you have questions. We've done this in the single system designs, but steps to creating a data set, we're going to enter variable names and then we're going to enter data. I'm going to go through this quickly because, again, if you decide you want to create a data set just for practice, I think if you use the couple of examples that the example surveys that I provided, it would only take you a couple of minutes. So we'll enter the variable names. What I've done here is just put up a screenshot of Excel, and in cell 1A, we're just listing student ID. We would put the second variable label, which was actually the first question on the survey, in box B1, PRG used, and so on and so forth until we had all of the different variables listed from the survey listed in the database. Now, if you remember, on that survey there were 10 questions, but there's actually 11 data points. So the first data point was that student ID number, and even though that wasn't a formal question, remember that's what we put on there to sort of associate the row in the database with the piece of information on that survey. And again, we do that in case we need to refer back to the paper copy of the survey for any reason. All right, next thing we're going to do is enter data. Again, this is exactly what we've done for in the single system design project. And so the sorry about that. I paused it real quick just to sort of make my screen a little bit bigger, so you could see the row numbers on the left-hand side of the screen. So again, we're entering a number 1 here because that was the first survey response we were looking at. Moving on, we would enter a 2 for the program that particular person used, right? If you remember, 2 was what we assigned to choice B, which I believe was the parent young child program, right? So on and so forth. So we could sort of fill in all of the data for person number 1. We could fill in all the data for person number 2. We could fill in all the data for person number 3. Person number 3 has a negative 99 for that last question. That simply means second to last question. That simply means that they left it blank again, and so on and so forth. Again, in this class, there's no particular assignment for creating a codebook in a database. But this, again, is all sort of in service of starting to analyze data in a couple of weeks. So we've got to be able to, sort of prepare data for analysis. So, practice if you want to. I leave that up to you. So once we've done this, we really now are ready to begin data analysis. And that's what we're talking about, sort of in the course of the next couple of weeks here. We're going to go through some univariate stuff. We're going to go through some bivariate and inferential stuff. We spend 2 weeks on the univariate piece, and we spend 2 weeks on the bivariate piece. I know that statistics are intimidating. We're going to go slow. We're sort of starting at the beginning. In univariate stuff, we're talking about mean, median, mode, standard deviation. I'm going to show you how to calculate all this stuff in Excel. We've got those synchronous sessions. We've got 2 of those coming up still this semester where we can sort of deal with questions. The other thing that we're going to do is the calculations are all pretty easy. And the reason for that is that you can double check your work by hand or with a calculator. Calculator and by hand, sort of the same thing. So you can double check what it is you're doing. They're not, the numbers that we're going to use are not so complex that, it would take forever to figure out by hand. And again, we're doing this so you understand the mechanics on a simple database, so that in practice, when you have to do it on more data or more complex data, you sort of understand what to do. Again, my point here is not, to sort of, intimidate folks with statistics and analyses and things like that. It's really, to sort of prepare you for the kinds of things that you're going to be asked to do as a practicing social worker. So, thanks for watching. And as always, questions, problems, or whatever, feel free to get in touch.